Hello and welcome to another installment of Math World. A couple of problems that we've been working on over the last several days. One of them involving this cargo service that charges an initial flat fee plus a certain rate for each pound. This particular function is pretty straightforward. I brought this up though, this whole video, not to talk about how to do this function work, although that will be a bonus. But the other thing I want to talk about is how can we effectively do work without a calculator and without doing a bunch of tedious, sort of cumbersome calculations. So in this case, I brought this up because $9.25, if I read the whole problem before I started doing it, and I found out eventually, I want to know how big of a package could somebody send if they only had $9.25. It's kind of a contrived problem, but nonetheless, I see $9.25, I see $1.50. I'm going to be working a lot with decimals here. I want to show you some strategies that we can use to work with numbers and graphs to make our work with numbers easier. So for starters, I'm going to understand my function. I'm going to think and plan before I start doing stuff. So the first thing I observe is C of x represents my cost in dollars, and that is the dependent variable because the cost depends on weight, which is measured in pounds. So I've defined independent and dependent variables, which enables me to complete my table of values. So x representing all the different weights. In part A, we're supposed to determine the cost of sending 1 through 5 pound packages. So I start with the obvious that 1 pound package is going to be $4 plus $1.50 for that pound. So it's $5.50 for a 1 pound package. All I'm going to do for the rest of this is add an additional $1.50 to each new weight because every pound that's added increases the price by $1.50. So $5.50, you add 50 cents, you're at 6, you add one more, you're at 7, and so on. Just making sure that all of these are $1.50 apart, and they are, so I know I've got the correct table of values. Most people would stop there. But did say plot the data in part B, so I'm going to oblige. As you can see, I want to point out a couple things about this graph here. Hold on a second. This graph was made by hand, and then I just pictured it in. But I'd like to point out, first of all, that I used a ruler to set the scale. That's fundamentally important. But I also want you to notice that the data, I didn't actually plot all 5 of these points to get this graph. I actually only plotted 2, plus I plotted 1 extra one to make sure that I plotted correctly or accurately. So here's what I did. I knew that a 5 pound package would cost $1.50, and I confirmed that over here. So I simply found 5, and using my ruler, I counted up the same scale to get to 11.5. I also knew that $4 would be the imaginary cost of sending a 0 pound package. So that's their initial startup fee. And so now we can connect those 2 points with a line. Some might ask, well, how do you know that that's a line? And the answer is, for each pound, this $1.50, this is a rate, $1.50 per pound, and that rate is constant. The term for each implies that there's a constant rate of increase in the price. For every pound, there's another $1.50 added, which creates linear functions. So, the point is, well, there's only 2 points. The point is, I only needed to plot 2 points to know where all the rest of the solutions to my function exist. I connect those 2 points with a line, and now I have solutions everywhere. So just to verify, I found the point 1.5850. So here's the point 5.50, $5.50, corresponding to 1 pound package. If I look where 1 is, and I follow it up to the graph, and I follow it over, it's consistent. So this line is consistent with my data is consistent with the line, so now I can move forward. Moving forward, I see that C of x, the cost, is going to be, well, I'm supposed to write an equation here, and I just want to point out how I translated the first sentence into an equation. It essentially says the cost is $4 plus $1.50 for each pound. That's English. And to translate that directly, cost, C of x, cost depending on weight, is, for equals, $4 plus an additional $1.50 for every pound. So if it's 0 pounds, we're talking $4. If it's 10 pounds, we're talking 4 plus 15 or $19. And you can see that this is pretty valid. But just to make sure for the reader that I'm thinking about my answer, I'm going to drive this point home by evaluating C of 5. Notice here that 1.5 times 5, I'm averse to that. I made it 3 halves times 5, which becomes 15 halves. You should be able to take half of 15, that's 7.5, and add that to 4 without much difficulty. So this isn't really the part I wanted to talk to you guys about, but I would definitely point out that I didn't work with decimals because my work with fractions is better. We'll see more of that real soon. Here's the money. We were given the fact that C of x is equal to $9.25. So what I did is I went to my graph and I found $9.25. I drew a line horizontally to the graph and shot it straight down. And my graph seems to indicate that a £3.50 package would cost $9.25 to send according to this scale. So my graph, which is pretty accurate, seems to reliably tell me that the solution to my equation is going to be $3.50. Now I could also look at the table and see that $9.25 is halfway between 10 and 8.50, so I'm thinking $3.50 again. So I already know before I ever start doing any algebra that £3.50 is going to be my answer, but I want to become better at dealing with mathematics, arithmetic, number sense, so I'm going to prove using algebra that that result is in fact valid. You'll notice the first thing I did is I converted the decimals into fractions. I highly recommend you do this because working in decimal form could become extremely tedious. So here, I see this in fraction form. It reminds me of what we've been practicing regularly, which is fraction busting. And I distributed the 4 on both sides. You might be wondering about 36 plus 1. I just distributed 4. Times 9 is 36, and 4 times a quarter is 1, so 36 plus 1 is going to be 37. Now I'm going to solve for x. I'm going to subtract 16 from both sides and divide by 6. And once again, instead of doing 20 divided by 6, I reduce the fraction to 7 halves, and 7 halves is very easily $3.50. Here's the beauty part. We're going to go back over to the table here and point out that $3.50, well, hold on, I'll go over here again. You could send, I answer the question in English, you can send a 3.5 pound package for $9.25. Now, here's my sense-making bit. This should make sense because we're adding $1.50 for every pound. Well, that means we're going to add 75 cents for every half pound. So let's go over here. Recognize that if I add a half a pound to the weight, I add 75 cents to $8.50, which puts me at $9.25. So I have a graph that says £3.50. I have a table in Common Sense which say £3.50 costs $9.25, and now I actually have algebraic and arithmetic proof of all of that. Notice then, all of these things confirming one another makes it so I'm less dependent on the calculator and I could use more common sense to approach. Students who do not think before they write would oftentimes solve the equation this way. And the problem with solving the equation this way is not that it's wrong. That is to say, I'm going to subtract 4 from both sides, and then God said draw a line under it, so I draw a line under it and I put the number in front of x underneath over here, whatever that means. Anyway, now a lot of students will freeze because they're asked to divide decimals. God said you can't divide by decimals, so I multiply top and bottom by 10 to get 52.5 divided by 15. So if you remember how to do long division, this is what you have to do. You have to take 3 times 15 is 45, and then we subtract the difference. God said bring down the other number, so now I figure out how many times 15 goes into 75, which is 5 times, and I get my 3.5. This kind of arithmetic gets you so far off the common sense approach that I do not recommend it, and it takes a lot of time. Instead, we could be a little bit more sophisticated, and what I mean is we could start by looking at the graph itself. And the graph itself shows me that I'm looking for 3.5 as a solution. So now I'm doing my problem and I'm looking at 52.5 divided by 15, and I don't want to do long division, but I'm pretty sure the answer is going to be 3.5. You can check that this is true by saying 3.5 times 1.5. If we multiplied 3.5 times 1.5, we should end up with 5.25. So here I'm going to multiply 3.5 and 1.5, but that's long multiplication. There's still a better way. I'm just going to do 7 halves, which is 3.5, times 3 halves, which is 1.5, and I get 21 fourths. Clearly 4 goes into 21 5 times with a quarter left over, which is matching what I had right here. So 1.5 times the 3.5 pounds is going to cost me $5.25. If we add the $4 to that, we get the total $9.25. So I can avoid long division and I can avoid long multiplication by using the graph to get a very reliable prediction. I could also use the table to verify that prediction is logical, and I can do some tricks and shortcuts with mental arithmetic, that all of which prevent me from having to do painful long multiplication and division. So very quickly, I'm going to go over this one. This one deals with the value of a photocopier. It's in euros, and the value depends on time in years. So when I'm reading this, what I see is we start with a value of around 9650, and what this seems to tell me is just like adding weight to packages, we're subtracting value every year. In fact, we're losing 860 euros every year. So this is me just understanding the problem. But here's another thing that I did to understand the problem. I was looking at 860, and I was thinking to myself, well, 10 times 860 is really close to 9,000, so I want to know what happens 10 years later. So when I do that, I get easy to calculate numbers. 9650 minus 8600 is 1050, 860 times 10. All of this is easy to calculate. You may ask yourself, if you read the problem, why would I spend any time and energy evaluating the value of the copier after 10 years? The answer to the question is, I know that 11 years later is probably going to be a worthless copier based on the work that I did, which enables me to make a graph. So my graph, I know, should only go up to like 11 or 12. I can plot the point that I found, and this was an easy to find point, and I know how much the value of the copier was in the beginning. So I know how much the copier was in the beginning. I know we lose the same amount each year. So here's my other point. And, sorry, hold on. I lost my train of thought. There was some clattering in the halls, and I got distracted. So I paused it and tried to remember what I was talking about, and something about this. Oh, yeah. So I knew that 10 years later the value of the function, or the copier, was this much, and I knew how much the copier was worth at the beginning. I knew there was a constant rate of decrease, and so I drew the line. Now, as you can see, using a ruler and very carefully, I find out when t equals 4. I follow that up to the equation, and I go over, and I could see that more than 6,000 is going to be my value after 4 years. So I look at part A. It's asking me to find v of 4 and state what it means. I know that it's going to be probably over 6,000 for sure. I'm going to guess 6,200. Now I actually have to calculate v of 4, and we get this. And I want to show you what I did here. I had to do 860 times 4. Here's what I did. I said 860 times 4, which is 800 times 4. That's 32 and 2 zeros. 6 times 4 is 24, add a 0. And so instead of actually multiplying 860 times 4, I did two simpler calculations. I'm going to subtract the 3200 and the 240 from 9650. This I can do in my head as well. And it turns out to be 6,210. And just estimating off my graph, I got 6,200. I was only $10 off, or 10 euros off here. So I'm really proud of this result, and I'm pretty sure that it's right. All I have to do now is interpret. V of 4 equals 6,210. In 4 years, the copier will be worth 6,210. Finally, the last question that I'm going to deal with on this particular video is the question where they said, well, what if the value is 5780? Then how old is the copier? So I already asked the question in context when it says, what does this represent? I already know this is the value, and how long is it going to take for the copier to be worth only 5780? Here's the thing. I'm thinking about what I just learned, and I learned that after 4 years, there's 6,210. 5780 shows a price drop of $430. My equation says we're losing $860 each year, so that means $430 is lost every half a year, which basically means in 4.5 years the copier will be worth $57.80. So I used my answer to part A to answer part B based on my understanding of everything that's happening here. So the graph says 4.5 is the correct solution. My common sense, dropping 860 to 430, that confirms my answer as well. But this is an algebra class, so I want to verify that I'm capable of doing my algebra. So here's the notation that's required. V of x equals 5780 means 5780 is equal to, well, V of x in its alternative form. I add 860t to both sides. I subtract 5780 from both sides. And here again, 9650 minus 5780, and you're thinking, gotta use a calculator. I say no. First of all, everything is 10 times bigger than it has to be, so I'm going to divide everything by 10. Smaller numbers equals good. Then I'm going to take the number 578 and break it up into 565 minus 13. I knew 965 minus 565 is easy. That's 400. Take away another 13. I can figure that out. That's 387. Divide that by 86. Well, here again, I don't want to take 387 divided by 86. That's hard. But I know the answer is 4.5 already. So all I have to do is verify that 86 times 4.5 years will get me to the cost of 387. And so to prove that one, I do a little bit of fractiony math. 43 times 9 is 387. Yay, I get all my points. So the only thing I'll do else, and I'm not going to write this because the video is long enough, this means that in 4.5 years the value of the copier would be 5,780. I know I went fast. I know I covered a lot of information. Please go back and revisit this because there's a bunch of different little skills and tricks that I dropped into this video that I think all of you, I'm trying to freak you out now, I think all of you would benefit from just learning a little bit more number sense, number skills, how to work smarter, not harder. That's what I should have titled the video in the first place. So enjoy. Thanks for watching. Have a great day.